So hey there, future statisticians! Have you ever wondered why averages don't always tell the whole story? So let us say you and your friends each score 80 on a test. Sounds great, right? But what if one person actually scored a 60 and another a 100? That's where the measures of variability step in to save the day. So why does variability matters? Measures of variability tells us how spread out or consistent our data is. It's like comparing a calm lake to crashing ocean waves. So variability shows the difference. So today we will dive into 3 simple measures of variability for ungrouped data, which are the range, variance, and standard deviation. Don't worry, we will keep it easy and fun. First up is the range. It's as simple as subtracting the smallest value from the largest value. For example, the data are 3, 8, 10, 15, and 20. So the range is equals to 20 minus 3, which is 17. So the range is 17. Easy, right? But remember, the range only gives us the extreme spread. It doesn't tell us about the distribution in between. So next, we have variance. It might sound scary, but stick with me. Variance measures how far each value is from the mean. So here's the formula. Variance is equals to the summation of x minus mean squared divided by n. So let us break it down. Number 1, find the mean of the data. 2, subtract the mean from each data point, then square the result. And 3, add up the squared differences. And lastly, divide by the number of data points. So let's work through an example. Data is 3, 8, 10, 15, and 20. The mean is equals to 3 plus 8 plus 10 plus 15 plus 20 divided by 5 is equals to 11.2. Now, we subtract the mean from each value, square it, and then add them up. And then after that, we divide it by 5. That gives us the variance. And finally, we have the standard deviation, the big sibling of variance. It's just the square root of variance. Why? Because variance is the squared units and standard deviation brings it back to the original scale of your data. For example, if your variance is 25, your standard deviation is the square root of 25, which is 5. Easy, right? So let's recap. Number 1, range gives us the simplest spread. 2, variance tells us how data points differ from the mean. 3rd, standard deviation gives variability in the same unit as the data. Understanding measures of variability helps you see the full picture behind the numbers. So if you found this helpful, give it a thumbs up and share it with your friends.
Hi everyone, I'm Chelsea and welcome to this video on measures of variability for group data. If you're curious about how to measure the spread of your data, you're in the right place. Today, we'll cover the basics, range, variance, standard deviation, and a few other key concepts. Let's get started. Let's start with the basics. What is variability? Basically, it's a way to measure how spread out or different the numbers in a dataset are. It tells us whether the data points are close together or more spread out around the average. Understanding variability helps us uncover patterns in the data that we might not notice right away. Key measures of variability for group data. Let's start with the range. The range is one of the simplest ways to measure variability. For group data, you calculate it by subtracting the lowest class boundary from the highest class boundary. It gives you a quick idea of how far apart the data values are overall. The interquartile range, IQR, measures the spread of the middle 50% of the data and is calculated as IQR equals quartile 3 minus quartile 1, where quartile 1 is the value below which 25% of the data falls and quartile 3 is below which 75% falls. It minimizes the impact of outliers. The quartile deviation is half the IQR, calculated as quartile deviation, equals IQR divided by 2. For group data, quartile 1 and quartile 3 are found using cumulative frequencies. These measures focus on central data variability while ignoring extremes. Next up are variance and standard deviation. This shows how much data points differ from the mean. For group data, we use class midpoints and frequencies. First, find the deviation by subtracting the mean from each midpoint. Then square these values, multiply the squared deviations by their frequencies, sum them up, and divide by the total frequency, or one less depending on the formula to get the variance. Finally, take the square root of the variance to find the standard deviation. These measures give a detailed view of how spread out the data is.
Hello everyone, I am Anya Dominique Margaret Madi and I will be teaching you about the measures of variability in grouped and ungrouped data through manual solving. So first, I have here is our data. I arranged it into a descending array so it is more easy to find and to avoid confusions. So here we have 40 as our n, or what we call the sample size. Let's move on to the ungrouped data. Ungrouped data can be complex as you have to input the data set to get an accurate result. Here, we are using the values of x minus mean, and the true value of x minus mean squared to make our solution easier to comprehend. Our range is 6, and this is through the formula of r is equals to the highest value, which is 23, minus the lowest value, being 17. So, step 1, we have to find the mean. In order for us to find the mean, we have to find the summation of x and divide it by our sample size, which is 40. So, here when we add all our data, it will add up to 768, and then we divide by 40. So now, we have 19.2 as our mean. So, moving on to step 2, x minus mean. This will be simple since we just have to minus the value of x to 19.2, which is our mean. This means that when we minus 23 to 19.2, we get 3.8. When we minus 21 to 19.2, we get 1.8, and so on and so forth. So next is step 3. Here is where we find the true value of x minus mean, and then we square it. So for further explanation, here we have 3.8 squared, we get 14.44, 1.8 squared is equals to 3.24, and all negative numbers will be considered as positive here. Step 4. Now we add all the values in x minus mean squared, and here we have the total of 70.4. To find the variance, we use the formula of v is equals to the summation of x minus mean squared divided by n minus 1. Since we already have the summation of x minus mean squared, which is 70.4, we now divide it to 40 minus 1, and that being 39. Now we have our variance, which is 1.805, or round off to 1.81. Step 5. To get the standard deviation, we just need to find the square root of this variance, and this is the square root of 1.81 is equals to 1.345. Or when you use the square root of 1.805, we get 1.344. Moving on to the group data. This is much more complex since we have to solve for our range. We also need to find k, which is the assumed interval, I being the actual class interval, and c for our classes. So step 1, we have to solve for the range, and as mentioned earlier, r is equals to 23 minus 17. So this equals to 6. So here we have k is equals to 1 plus 3.322 logarithm 40, and that will be 6 as well. Our I is 6 divided by 6, and that will be 1. And lastly, we have 6 divided by 1, and that is equals to 6. So next, in order for us to have 6 classes, I added values 13 to 16 for it to fit. And here we have the classes, F being frequency, CM being class mark, F times CM, mean, CM minus X squared, and then F multiplied by CM minus X squared. So X being our mean. So step 3, here in our classes, we just have to be mindful of our interval being 1. So since we need to have 6 classes, I added 13 to 14 and 15 to 16. Moving on to frequency. Here in frequency, we just have to find how many times that the numbers in a class show up in the dataset. So here we have the class 23 to 24. 23 showed up 2 times. In class 21 to 22, 21 showed up 4 times. And in class 19 to 20, 19 showed up 13 times and 20 showed up 7 times. We just need to add 13 and 7, so we have 20. So after you finish solving, you have to add them to find if your sample size is correct, and that being equals to 40. So next, we have the class mark. So the class mark is determined by the lower limit plus the upper limit divided by 2. So here we have 23 plus 24, and that equals to 47 divided by 2. We have 23.5. So you do this to all classes and then add it all up, and you have 768. So next, we have to find the mean. So to find the mean, as mentioned earlier, we have to divide 768 to 40, and then we have here 19.2. So you just input 19.2 in this section, which is the mean. So moving on to class mark minus mean. So this means we have to minus the corresponding class mark to 19.2. So we have here 23.5 minus 19.2, we will get 4.3. Another one is we have 21.5 minus 19.2, then we will have 2.3, and so on and so forth. And next is we have to square our results in class mark minus mean. So we have 4.3 squared is equals to 18.49. 2.3 squared is equals to 5.29, and again so on and so forth. So next, we multiply the corresponding frequency to the class mark minus mean squared. So here we have 2 times 18.49, we will have 36.98. And then we have 4 times 5.29, and we will have 21.16. 20 times 0.09, we have 1.8, and we continue until we finish it all. So on and so forth. So next is once we get all values on f times class mark minus mean squared, we have to add them all. Hence, in the formula, the summation of frequency times class mark minus mean squared divided by n minus 1. So once you find the total, we now use the formula to find the variance. So here is 100.4 divided by 40 minus 1, and that will be 39. So 100.4 divided by 39 is 2.6. So next is we will find the standard deviation, and once again, just finding the standard deviation, we will have to square root 2.6, and this will result in 1.61.
Hi, my name is Jeter Paul Dignadice. I'm from 202P, and I'm here po to discuss how to get the measure of variability using Excel function. So, Measure of variability are the spread of values about the mean. Smaller dispersion of scores arising from the comparison often indicates more consistency and reliability. This includes range, variance, and standard deviation. So, first one is range. It is the difference between the largest and the smallest value. Ang formula po natin is highest value minus sa lowest value. And para makuha yun, it equals 23 highest value minus 17. Enter. Ang range natin is 6. And next is the variance. It measures how far each number in the set is from the mean. So, ang formula po natin is sigma squared is equal to the quantity x minus mean squared over n. Ang sigma squared po natin is ang variance, ang x is an individual score, x bar is the mean, n is yung number of scores natin. So, una, para makuha yung mean, kukunin natin yung sum nitong scores. Then, may formula tayo sa mean which is yung sum of the mean scores divided by the number of scores. So, ipapag-class natin sila. Kunin natin ang sum. To 23 and enter. We get 768 and divide natin sa 40 or sa mean. Click this one, then divide 40. Get 19.2. Ilagay natin siya sa mean. Then dito sa column na to, kunin natin yung score 17 and minus natin sa mean. Enter. We get negative 2.2. Another, kunin natin yung score minus sa mean. Enter. We get negative 1.2. And dito naman po sa another column is kunin natin yung sagot natin doon, then scored natin. We get 4.84. Another, natin yung sagot natin, then square root and enter. We get 1.44. Then para makuha yung variance, kukunin din natin yung sum nito. Sum 4.84, 14.44 and enter. We get 70.40, then divided by 40. Click natin to, divided by 40. Ang variance natin is 1.76. So the next one is the standard dev. It provides some idea about the distribution of scores. So ang formula po natin is SD to the square root of the summation x minus mean squared over n. Ang SD natin is ang standard deviation. Ang x natin is in yung individual scores, and x bar is the mean, and n is the number of scores. Then i-square root lang natin ang variance natin. So square root, click we get the standard deviation of 1.33. May mas simple po na paraan para makuha yon, which is ito, equals variance population, then kunin natin yung sa data, and enter. We get 1.76 din. Dito naman kunin natin yung standard deviation. 1.32. So ngayon, tuturuan ko naman kayo kung paano kunin yung measure of variability sa group. So, yun, una, i-ascending natin siya. Yan. From lowest to highest, then next is gagamit tayo ng extension, which is yung toolpath. Ito, maraming pwedeng pagpilian. Merong linear regression, to sample of variance, t-test, may ANOVA din, and correlation and others. Pero scripted statistic tayo. Una, yung input range natin is yung natin yung data. Click yung input range. Sa output range, kahit ano. Yan, example dyan. Yan, okay. Hindi. Yan. Yan, okay. Ito. So, ang mean natin is 19.2. Standard deviation natin is 1.3, 1.34, and ang variance natin is 1.8, tapos ang range natin is 6.
I will now show you how to compute the measures of variability and group data using SPSS. This data we used is from the students in GRU. So let's start. First, we select Analyze, Descriptive Statistics, and then Frequencies. By here, we move the variable we want to see the measures of variability for. I'll select age. Then next, we select statistics. In the bottom of this, there is dispersion. Here, we will select the measures of variability we want. Now, I'll check the standard deviation, variance, and range. Then, under ng percentile values, i-check natin ang quartiles. Ibibigay nito ang first, second, and third quartiles. Then, click continue. Since we only need to compute measures of variability, we'll remove the check of display frequency tables. Then, click OK. So, this is the output. We can see the standard deviation for age, which is 1.344. The variance is 1.805, and the range is 6. The first quartile is 18, the second quartile is 19, and the third quartile is 20. Okay, so this is the complete solution of how we get measures of variability using SPSS. Okay. So first, we're going to make this data into group data. Okay, so in this data set, one of the variables is age. So to group the data, we first select transform and then visual binning. In the new window, select what you want to transform. I select age, then continue. Next, another window. Here in the binned variable, we need to make another name. I'll put age underscore grouped. Also, if you notice, it is reflected here the minimum and maximum value of the dataset. Our minimum value is 17 and our maximum value is 23. Then, let's select excluded. If you notice this graph, we will divide it. To make that happen, let's select cut points. Sa under ng equal with intervals tayo. So, our first cut point location is 17. The number of cut points is 6, but there is a note in the bottom saying that n cut points produces n plus 1. So, let's make the number of cut points as 5. Then, it will automatically compute the width. Then after that, select apply. As you can see, there are no 23 here. You just change this into that. So, 21.8 plus 1.2 is equal to 23. Then after that, click make labels. Then click OK. So, once we made this into group data, let's now compute the measures of variability. Again, we select Analyze, Descriptive Statistics, and then Frequencies. Move the variable we want to see the measures of variability for. Select Age Group. Next, we select Statistics, Dispersion. Again, here, we will select again the measures of variability. Now, I'll check the standard deviation, variance, and range. Then, under ng percentile values, i-check natin ang quartiles. Ibibigay nito ulit yung first, second, and third quartiles. Then, click Continue. Since you only need to compute measures of variability, again, we'll remove the check of display frequency tables. Then, click OK. So, this is the output. We can see the standard deviation for age group, which is 1.310. The variance is 1.717. And the range is 5. So, this is the complete demonstration of how we get measures of variability using SPSS. Thank you.